Hello, welcome to my Physics 2 Lab 2 report on charged tapes revisited. The program to this lab is on the left-hand corner. You can click it in my report. Video lab report. Also, just a heads up, being that this is a coded lab, there's not really any observations to point out, besides the fact that the charge for the tapes we calculated in the previous lab were different than the ones we calculated in this experiment. I do provide a detailed look into the model I coded, so as per rubric, I followed everything that was given. The purpose of the lab is to recreate the concept we demonstrated in Lab 1 using GlowScript. However, the only difference is instead of treating the tapes as a point charge, we are treating the tapes as if the charge was spread out in in sort of bins, each tape split into different sections with a charge. So we will also see the extent of spreading the charge on the tape over multiple bins affects the previous charge we calculated, and we also see the difference between the two Lab 1 and Lab 2's calculations and the results. The fundamental physics principles here are, of course, net force, the sum of all forces acting on a system, being that we have now multiple electric forces on one piece of tape acting on another piece of tape in different areas. This will be very important. The electric field is also important. We have multiple electric charges in each bin, meaning, and the electric field is just E equals kq over r squared. Gravitational force, of course, is affecting the top tape, which is F of g equals negative mg j hat. And the system, or the source under study, is the top tape that is floating, while everything else, such as the bottom tape and Earth's gravity, is the surrounding. What The magnitude of the charge on one piece of tape for this model was 1.10 times 10 to the negative 7 C. That's what we calculated in this model, which is more accurate than what we got in the last model in Lab 1, which was around 1.4 times 10 negative 5 C. This means that using a point charge increases our estimate and makes it less accurate than using a much more spreaded charge. What we approximated in this lab is that we are assuming that each U-tape has the same amount of charge and is evenly distributed the same amount, meaning they affect each other the same amount. We're not assuming it's a point charge, but we're just assuming they have the same charge and it's spread out the same, which it most likely is not. Of course, I wanted to show you from the previous lab how we model what the model would look like. As you can see in the force diagram, we have gravity pointing down, the electric force pointing up. And since B tape is just floating, there's the net force on the top tape is 0. I also have some of the real data we collected from the last lab, including the fact that the tape weighed 1.6 grams, which allowed us to calculate the gravitational force, allowing to calculate the electric force. And the gravitational force was around 15.68 newtons, which helped make this program possible. So here's what the code resulted in. As you can see, the magnitude of the electric force, or well, the charge on the tape was 1.1043 times 10 to the negative 7. But the magnitude of the electric force of the tape was 0.0158, which is around the same as the gravitational force. On the left, you can see the constants of the code. We also have the function for calculating the electric field on each bin and making the tapes on the bottom. We also have the code for the top tape and the bottom tape and making their vectors, by calculating their electric field forces for each bin. And of course, we have the code for making more of the vectors and scaling them down. And this is just the end showing the vectors and printing out the values we get. So what if we have modeled each tape as a single point charge like in the previous? Well, we already said it before. The estimate would have been much bigger than the estimate we calculated and would be much more or less accurate than Lab 2, the one we did in this experiment. And why do the estimates differ? Well, it's because the charge itself on each tape is actually spread out. Of course, our estimate we calculate in this lab is still not accurate enough. We'd have to spread it out an infinitely number of bins, but we can only do so much with code. If we want to do infinitely amount of bins, we have to use an integral, which we did not code. Some sources of error, I could have increased the number of bins to be more, make it more accurate, and I may have measured the weight of the tape wrong.